All right, these are your Chapter 5, Section 1 notes. Your objectives for this section is going to be explain the roles of Mendeleev and Moseley. Make sure you get good notes on both of those guys. Describe the modern periodic table, explain how the law can be used to predict properties, and how the elements belonging to a group are related. All right, Mendeleev was the first person to make a periodic table. He was the first one to organize elements in the formation of the periodic table that we have. Now, something very important though, you want to take note of is make sure you know that when he first did it, he did it by atomic mass. Okay. What happened? There we go. Okay, so make sure you know that Mendeleev organized this table by increasing atomic mass. All right. Keep in mind that right now it is organized by increasing atomic number. All right, but he did it by mass. Now, when he did that, he noticed that certain chemical properties appeared at regular intervals. Okay, he noticed repeating patterns, and he called them periodic, which is where the name came from. All right. He created a table where elements with similar properties were grouped together, and they still are. So make sure you know Mendeleev was the first one to do that. All right. After he placed all these elements on this table, he noticed that there were several empty spaces. Okay. In 1871, he predicted, this is important, very important, Mendeleev was able to predict the existence and properties of elements that would fill these empty spaces that he found. So they did not even exist yet, but he was able to predict their existence and some of their properties. All right. And then, of course, by 1886, all three of them had been discovered, and he predicted them many years before. These are those three elements that he discovered. This is what he called them. He called them this. This is what they actually were. Okay, this is what we call them today. And this is the most interesting thing. See, here are the properties that he predicted them to be. And then here were the actual properties here. So you look how close he was. You know, density, melting point, melting point here. Again, density, how close that density is. So he was able to very closely predict these elements. Now, also very important you have in your notes is that later on, Henry Moseley came along, and he's looking at this periodic element that Mendeleev did, and he's noticing that there were some discrepancies. So there were some things that there were some issues with it. So he changed it, and instead of increasing by atomic mass, he changed it to increase by atomic number rather than the mass, weight or mass. Okay, so very important you know what each of those men did and how Moseley changed the periodic table to increase by atomic number instead. It ended up being a subtle change. Just a few elements got switched around, but it did just help alleviate those few discrepancies that it had. This is a vocab word, so you'll get this in your vocabulary, so no need to write it down. Periodic table, also a vocab word. All right. I could just, okay. Okay. Make sure we got some volume.
There are 92 naturally occurring chemical elements or atoms. They differ in the numbers of protons, neutrons, and electrons they contain. The periodic table arranges these elements in order of complexity. For example, hydrogen, element 1, is the simplest atom because it contains only one electron and one proton. It appears at the top left of the table. Uranium, the most complex of the naturally occurring elements, has 92 electrons and 92 protons. The number of protons in an atom is the same as its atomic number. The atomic number for each element appears just above its letter abbreviation. The periodic table also arranges elements together in groups or families. Elements in a vertical column are called a group. The elements in a group have similar chemical properties. For example, the noble gases on the rightmost edge of the periodic table have great stability and limited reactivity with other elements. Group 1, the alkali metals, have similar reactivity. They readily form hydrogen gas when added to water. A horizontal row of elements forms a period. The differences between elements in a period and elements in the next period are consistent between the groups. For example, if we look at the difference between elements in group 18 and in group 1, we see that the difference in atomic numbers is constant. 8, then 8, then 18, then 18, and then 32. This means that the atoms are consistently becoming larger by a set number of protons as you move from period to period. Note that there's a special block of elements below the main table known as the lanthanide and actinide series of elements. They are grouped together and placed below the main body of the table to keep it from becoming too wide. Elements with atomic numbers greater than 92 do not occur naturally, but can be produced in laboratories. Most are not very stable and decay rapidly.